Alright, in this video we're going to be working on decompositions of partial fractions, and what we're going to be looking at is taking this expression here and breaking it up into the addition of two other fractions. And so here's our process. The first step that you want to do is you want to factor your denominator here. So this factors to x minus 3 and x plus 2. Alright, with that being said, if I were to break these up, then the x minus 3 would be one of my partial fractions, and the x plus 2 would be the other. So what we want to do is, we're trying to figure out what the numerator is going to be. So we let the numerator equal a and b for each of these fractions, and we're going to set the problem up as if we were trying to equal this. And we do that by doing a common denominator. So the common denominator between both of those would be x minus 3 and x plus 2. Now, in order for me to rewrite this fraction, I have to multiply a times x plus 2, and I'd have to multiply b times x minus 3. This is how we get our common denominator. So this is a times x plus 2 and plus b times x minus 3. What we're going to do is go ahead and distribute the top, and so we've got ax plus 2a plus bx minus 3b. Now, this is all over our common denominator of x minus 3 times x plus 2. But what I really want is I just want my numerator to equal x plus 7. Just the numerator. So that's what I'm going to do next, is I'm going to set x plus 7. I'm going to set it equal to my numerator, and I'm going to go ahead and group a few of these together. So I'm going to group all of my x's together, ax plus bx, and I'm going to group my constants together, 2a minus 3b. Okay, so here's what I know. I can take an x out, so this is x times a plus b. And then this is just my constant, 2a minus 3b. Well, if these are going to be equal to each other, then a plus b must equal 7. So here's the next step into this process. This a plus b has to equal 1, which is the coefficient of my x. 1 times x, 1 times x. So we set a plus b equal to 1. And we set our constant of 2a minus 3b equal to the constant here of 7. So these have to be equal to each other. And now we're going to solve the system for a and b. I'm going to multiply the top equation by negative 2 and add it to the second equation. And so this is a plus b equals 1. My second equation becomes 0a minus 5b equals 5. We know that b is equal to negative 1, and if it's a minus 1 equals 1, then a is equal to 2. That's the back substitution. So I put this negative 1 back in here. And what I've just done is I have found my a and my b values. A is negative 1, or sorry, b is negative 1, and a is 2. So here's how we would write our final answer. I'm going to go ahead and write it on top here. A is, so it's 2 over x minus 3. And b is negative 1, so I can do minus 1 over x plus 2. And there you have it. This is the solution here. This is how we can do the decomposition, which means to take the expression and break it into the addition or subtraction of fractions. All right, let's go ahead and try another problem here. So the first step is to try to factor your denominator. This will factor, I can take an x out, and I've got x squared plus 2x plus 1. So this is x, x plus 1, and x plus 1. Now the tricky part is when we break these up, this is x, x plus 1 to the second. We need to include all multiples of. So this is going to be 3 separate fractions. And the 3 separate fractions are, I have one that's over x, I have one that's over x plus 1 to the first, and I have one that's over x plus 1 to the second. And so you want to do all multiples of x plus 1 leading up to that highest degree of 2. You do this as a and b and c. And I'm looking for to write a common denominator between all of these so that I can change my numerator. My common denominator again would be the x plus 1 to the second. So that means I would have to multiply my a times x plus 1 to the second. This is how I change my fraction. I'd have to multiply this by x and an x plus 1. And I'd have to multiply c by just an x. So I've got a x plus 1 to the second plus bx times x plus 1 plus cx. Well, what I need to do here on top is I need to FOIL my x plus 1 and then distribute the a. A times x squared plus 2x plus 1 and plus bx squared plus bx plus cx. I'm going to go ahead and distribute my ax squared plus 2ax plus a, and I still have the bx squared plus bx plus c. You can see here that I am ignoring my denominator. I don't really need the denominator at this point in time. What I want to do now is group all of my x squareds together. So I've got ax squared plus bx squared. I'm going to group those. I'm going to group all of my x's together. I've got 2ax plus bx plus cx. And then I've got my constant, and my constant is the only one that I have in there is plus a. All right, factor out my x squared, and I have a plus b. Factor out my x, and I'm going to have 2a plus b plus c and plus a. All right, now I'm ready to go ahead and write my equations. My coefficients here, I've got 5x squared. So what I know is I know that a plus b must equal 5. And I've got 20 for the coefficient of x, so I can do 2a plus b plus c is equal to 20. That's this component. And then I know that what my a is supposed to be equal to. So a, which is the only constant, is equal to 6. So now what I can do is just, I got a is equal to 6. I can do some back substitution. So I know a equals 6. And if I do this, then b would have to be equal to -1. And if I put them all in here, then let's see what we get. I'd have 2 times 6 plus the b value, which is -1, plus c equals 20. I'm just back substituting. This is 11 plus C equals 20. So C would equal 9. So I've got all three values, and now we should be able to write our equation. So the equation is 6 over x, A. B was -1, so I can do -1 over x plus 1. And C is +9, so plus 9 over x plus 1 to the second. So right here, this is my final answer to the decomposition. All right, let's take a look at here this next problem. And it's, if for some reason you do not have this in your packet, please write or change your equation here. We want to try to do x squared plus 3x minus 4. And the first step, though, the first thing that we have to do is we have a power on top that's obviously larger than the bottom. So I need to do some long division. I need to do x squared plus 3x minus 4, and I need to divide into x to the third plus 2x squared minus x and plus 1. So long division, this is going to be an x. I'm going to distribute that down, x to the third plus 3x squared minus 4x. Subtract negative x squared plus 3x and then plus 1. Divide one more time, that's minus 1. So we get negative x squared minus 3x plus 4. Subtract, that's 6x minus 3. All right, now the part that we're worried about, or the one that we need to pay close attention to, is the remainder. We're looking at the remainder. So we actually need to do decomposition of 6x minus 3. And you see that here would be over then what we divided by, x squared plus 3x minus 4. So now we're kind of starting our problem from here. All right, so this is temporary, so we could get the remainder. We will use this in our final answer, but not quite yet. All right, this factors down then to x, let's see, plus 4 and an x minus 1. A and B, you replace the numerators. Those are just our unknowns. That's what we're going to try to find. And now what I need to do is I need to do the common denominator work. And that's x plus 4 times x minus 1. And this would have to be a times what was missing, x minus 1, plus b times what's missing, x plus 4. So this would be, I'm only going to the numerator now, ax minus a plus bx plus 4b. Regroup them together, so you've got ax plus bx. I'm grouping them so that I can factor an x out. And then I'm going to group plus negative a plus 4b. There's my constant. All right, this would be x times a plus b and plus negative a plus 4b is my constant. All right, here's my system of equations then. It would be a plus b equals, and so I'm looking at the coefficient, it's 6. So a plus b has to equal 6, and negative a plus 4b has to equal negative 3. That's my constant right here. And if I solve this system, I can go ahead and solve using my old methods. It's 5b is equal to 3. So b is equal to 3/5. That's not very nice. Let's find our a value. So our a value, I need to go back and substitute. So a plus 3/5 equals 6. So A is going to equal, if I take 6 minus the 3/5, then that's going to be 30/5 minus 3/5, 27/5. All right, time to go ahead and figure out and write my final answer. So let's go ahead and add another page here. I've got my answer to be x minus 1. That's the first part that we got. That was the division, but we have to use that in our final answer. Then I've got plus my a value. Well, my a value was 27/5. So 27/5 over, and it was x plus 4. Plus, and it was 3/5 over x minus 1. Well, this is not how we're going to leave our final answer. In fact, what we're going to do is just bring the 5 down on both of these fractions. So here's my final answer, x minus 1 plus 27 over 5 times x plus 4 plus 3 over 5 times x minus 1. And there you have it. Again, this is how you do the decomposition of our rational expressions. And here is your assignment.